to death with a bunch of AI technology. So, welcome. Good. How are you guys? Welcome. That's the best seat because I was telling these other guys the slides didn't come out as large as I would have thought they came out. So if you're in the back, you're probably not going to be able to see it or read it. So, yeah. I'm blind, so right there with you. Welcome. All right, Alex, do you need to do anything back there, or are you good? All right, perfect. All right, so thanks everybody for coming. If you're here, you can probably read the screen. We're going to talk a little bit about when, how, and why AI, and try to kind of apply that to some Department of War principles. Some of the things that I'm going to cover today go into some of the deep technical architectures, the tooling around AI. I'm going to try not to spend a ton of time there. So I like to ask this question up front, and I kind of talked to this gentleman a little bit. How many actual technologists do we have in the room versus kind of functional folks that are just here to kind of learn a little bit more about AI and how to use it? Just get a temperature of the room. Technologists, raise hands. Couple. Non-technologists, pseudo-technologists. Okay. So we got a kind of a little bit of a mixed room, which is totally fine. So for the technologists in the room, I may ask you guys questions, ask you to interact. If you've got something to add, feel free. Obviously, there's a microphone there. The microphone is on. It's hot. So if you have questions, you can pop up to the microphone. If you've got a loud voice, you can just sit in your seat and ask questions from where you're sitting, okay? So a little bit about myself. So Darren Stevenson. I work for a company called Apex Systems. We're an IT solutions company. We cover pretty much the spectrum of all IT technologies. We do have a few kind of lightweight products, accelerators, what we kind of call them. My role within the organization is the technology executive for the public sector. So I only focus on serving the public sector. I work with a lot of service integrators. We don't prime work, we only subcontract. So I work with all the SIs, some of the small businesses that you've seen downstairs, some of the product manufacturers as well. A lot of my role is taking technical concepts and trying to figure out how do we build and productize solutions that we can take to market for our clients. So a little bit about myself. All right, so I think it's good to kind of start at the beginning, right? The mission context, why we're here. In the Indo-Pacific region, you can see on the right-hand side, that's us, the little dot there in Honolulu that is not that large compared to everybody else out here. So we're kind of in the middle of the Pacific Ocean, trying to figure out how do we defend this enormous region that you guys can see on the screen. How many folks in the room, I know we've got some military folks, are directly responsible for like any ISR surveillance type of work, anything like that, intelligence work? Just kind of curious. Yeah, intelligence. Okay, a couple folks there. Okay, cool. So you understand and grasp the difficulty of trying to service this region. it's definitely not an easy task at all. So when we think about some of the current situations in the Indo-Pacific region, I'm sure you folks are familiar with these. We've got the Taiwan Strait tensions, the South China Sea disputes, right? North Korea provocations. I was in the Air Force actually about 18 years ago. I was an avionics engineer, worked on the B-2 bomber, and I remember we would deploy out to Guam, and that's when they were really aggressive about testing nukes, and so we would constantly have to, load up the bombs and deter them from actually doing more tests. So definitely a challenging theater. There's a lot of different logistical things you've got to work through here that you don't necessarily have to work through in other regions that we defend. All right, so let's break down a little bit of the high-level AI overview. If you look at this slide, all of these different technologies on the left, and this is not an all-encompassing list of AI technologies, by the way, it's just kind of a subset of technologies that lead to an overarching AI ecosystem. So if you think about machine learning and deep learning, predictive analytics, information extraction, speech to text, some of the NLP type concepts are embedded in that as well. Image recognition, computer visioning, all those different technical concepts are a part of what we're trying to build with this AI ecosystem in order to defend the theater. Now, one of the things that I think a lot about as I'm trying to work with our customers and bring solutions is, okay, there's a ton of different tools, a ton of different technologies, right? For me and for my customers, there's a lot of chaos, right? There's a lot of noise in the marketplace. There's a lot of AI hype. So separating the hype from the reality is sometimes the most difficult part of actually implementing effective AI that produces value, okay? So understanding there's a ton of tools doesn't necessarily do anything for you. It's understanding what do the tools actually do, what technologies are best used to deploy against what use cases. And so we're going to talk through some of that here today. We're going to talk through some of the higher level technical concepts, and then we're going to break that down into how to uncover AI use cases within your business units, your military units. And then secondarily, we're going to have a breakout session. That'll kind of be the last half hour where I'm going to ask you guys to kind of turn to your neighbors, think through some specific use cases within your business units that we can discuss here as a group. And then we'll kind of give it the real-time validation test, yes or no, hey, we think that's a good use case. We think we could use AI to solve that. Or if we don't think we could use AI to solve it, why not? Okay, sound good? Got to get my clicker here. All right, so this slide really kind of covers machine learning. So some of you may be familiar with machine learning, some of you maybe not so much. I know some of you probably can't see the diagram in the back. I apologize for that, but I promise you it's there, and it's got some really cool stuff on it. So on the top there, we talk about training data. That's the first step, right, when you're talking about machine learning. You have to have a good set of data to train the model. A lot of people don't fully grasp how important it is to have the right data, accurate data, valid data if you're going to train a machine learning model. Your machine learning model will only be as good as the data that you input into the model, right? Next, as you're training the ML algorithm, that's the piece where the data is then being used to actually program the algorithm and start to make sense of the data, right? And then the next one down there is inputting data. That's after you have the algorithm trained, you're going to continuously input new data, right? We live in a world where information moves extremely quickly. The pace of innovation across AI and just information in general is astounding. It's why I have a job in general, to be honest with you. But there's so much new information that has to be inputted continuously in order for a machine learning model to be effective. So you've got the original data that you've trained on, you've got additional data that you're continuously training the model on, and then that leads you to a prediction, right? Ultimately, you want a machine learning model to predict something and to give you an output of value, right? So that's that right-hand side. You're going to get a green thumbs up, red thumbs down, depending on how valid that use case is in predicting whatever outcome you want. Now, if you get a thumbs down, well, what do you think happens? There's technologists in the room. Your model comes back and says, hey, that's not what we want. That didn't match the value that we expected. What do you do next? Anybody got any ideas? We talked about the importance of data.
Just give it more data or more access?
Yeah, it could be more data, right? But we want to make sure we're giving it the right data, the most accurate data. That's probably why you got a thumbs down. The data that you used to train the model was not the right data needed to get the outcome produced that you wanted, right?
Data labeling or data actual, because I mean, do good data just labeled bad?
Yeah, so he said it could be good data that's labeled bad. Correct. So a lot of our clients come to us and they ask us for data labeling services. They have thousands, tens of thousands of documents and data sets, but they're not labeled correctly in their database. They've got unstructured databases. They don't know what to do with it and make sense of it. If you go downstairs, which I'm sure you all will later, there's companies that actually specialize in just doing that. But you have to have the right data set in a machine learning model if it's going to be effective. So that's a great point.
I think, like, to your point, I think it's knowledge management when it comes to organizations. This is the military, they kind of suck at knowledge management as far as tagging, cataloging, filtering, correct data, current data. Like you said, the AI is only as good as the data being injected into it. If you have wrong, outdated, wrong version of the data, it's not going to give you the correct output for what you need today. So a lot of people are stuck on AI is the way, is the future, but in reality, how good is the data? Because AI is only as good as the data. So I think it's
100%.
AI is the future, but how good is the data for how it works?
Exactly. And you're bringing up a point that's really valid, where a lot of people want to deploy AI technology, but their data sets are not set up to do it. And when you pop the hood and you walk in there, you're like, you're not even close to actually implementing any real AI. So you got to get the data set correct first. Question in the back there?
Well, it's at first pinpointing what is the wrong piece of data in your machine learning algorithm. And then it's going to back to categorizing it. And when we talk about categorizing, we're going to talk about compliance. So all of that needs to be tied in to move forward with AI.
Yes, correct. Great point. Right here.
You brought up a good point about knowledge managers. Does AI get rid of the need for us to have structured data in armies of knowledge managers, meta tagging things all day long, and just keep going and get data?
Yes, you can do that. You just don't have a switch you can turn on that solves that. He talked, I think, a little bit about agentic AI. We'll get there, but that's where you actually have AI agents doing work, talking to each other, interacting with humans to solve real problems and actually automate not just tasks, but workflows, right?
How do you get past the ontology problem? Because you have typical common data, this, and that's another thing I've learned that we've been having issues with. Just, you might call this, if you're data tagging, somebody else calls that, and you could be training data, or it misleads it, or something like that. And that's where I find a lot of the problems with my group is like the commonality of, you have the intel, the ontology of stuff. Either best case or best practices for just doing that initial ontology?
There are tools and technologies that are out there that help with that, right? It's not something that should be done manually by an individual. We can talk about maybe some specific tooling and things like that, after. But that is at the basis of the issue that he described over here in the corner. You have to have the data labeled correctly. You have to have it categorized correctly. And if you're dealing with vast amounts of data like we are in this setting, in this theater, just within the DOW, Department of War, I got to get used to DOW. There's so much data that it's really hard. It's a big problem to solve, right? So no one person's going to do that. Any other questions, comments on ML? Okay. All right, so the next one here is natural language processing. I'm sure a lot of you have heard of natural language processing. How many people have used like ChatGPT, Copilot? Yep. So underneath that hood is really, natural language processing. That's just the interface that you're using to access a large language model. A lot of that human-machine interaction can be text-to-speech, piece of text. You can use pictures to interact with the models. I'm sure some of you guys use pictures to interact with ChatGPT or Copilot, et cetera. But natural language processing coupled with machine learning is really the bedrock and the foundation, the engine, if you will, for what we'll talk about here in a minute, which is large language models. And once you get into large language models, that's where you're really starting to produce value with AI, I think. Now, my personal opinion is that there's just so much hype around AI and so much misunderstanding and misinformation that a lot of times what we think is possible isn't possible because we're watching movies or commercials and they're overhyping some specific tool and what it can or can't do. In reality, it's important to remember that all of these technologies are just programs, right? It's code, it's running, it's operating in the way that the intended programmer wanted it to. And so you can implement bias into these models and all kinds of different things. I know there's videos online on social media, right, where somebody is messing around with ChatGPT and trying to get it to give it certain responses or show that it's biased. Well, it is, right? Because whoever programmed the model is going to create the bias that's embedded into the LLM itself. So we've got to be careful with some of these technologies as we're implementing them, that we're not using a biased thought process that is going into the model that's going to skew ethically what the model is supposed to produce. So it's a big challenge, especially within the DoW and just society in general. Has anyone seen like the Social Dilemma documentary on Netflix? Came out like 2020. Yeah. If you have kids, you should watch that. It's crazy, right? You got social media companies. I've actually met with some of them in Silicon Valley when I was focused on the commercial segment. And they're essentially using machine learning, now natural language processing with ChatGPT, these other interfaces, to really manipulate people, right? They're trying to keep you engaged. They're trying to sell ads to you and make ad revenue. And you can really brainwash people with these technologies if you're not careful, right? So just a little bit of a side note there. You always need to be extremely cautious as you're dealing with these technologies that you're not implementing bias into the model yourself. Trying to move through this quickly because I got the timer here. I don't want to get stuck on any one area. All right, so we talk about Gen AI, large language models a little bit. If you look at the layers of generative AI architecture, some of you in the back, I know you can't see that, so I'll kind of point that out to you. You've got your infrastructure layer, your application layer, your model layer and hub, your LLM ops and prompt engineering layer, and then the data platform, I can't even read that, API management layer, right? So all of these different parts of the generative AI architecture is how you kind of formulate a large language model. Some of the largest language models out there is like OpenAI. There's Palm that was created by Google. That's what Gemini runs on. What's the other one? Meta AI has one too. I can't think of the name. Llama. Their model's called Llama. But there's a lot of these different models that are out there today. What I'm getting in terms of the Department of War and specifically how they want to implement it is they're looking to implement proprietary LLMs because they don't want to connect to external data sources, right? And especially if you're operating in this theater, right, where you've got air-gapped networks and you've got challenges around the infrastructure and how you get information into and out of these models, it creates a really challenging situation to build an effective LLM that can actually be leveraged for value. And so a lot of times what I'm talking to clients about is how do you solve that issue, right? Does anyone have any suggestions, or have you guys dealt with any of this in the real world as you're trying to implement LLMs, like proprietary on-prem LLMs that can then be connected through air-gapped networks, anything like that? Has anybody done? Okay. Can you talk a little bit about some of the challenges around that, just for the group? Because I haven't actually done it, so I'm just curious myself.
Yeah, so, we have a corporate network, and, we don't want, it has firewalls for the public internet, so we downloaded a 7 terabyte large language model, ported it over, from the public internet, and the simple problem we're trying to solve, this was a couple years ago now, is that when we sell things, we sell them to resellers, I was doing paperwork, right? So figuring out what of our install base, which DoD customers have, like it might say U.S. Air Force headquarters, even though it's off the airport,
Mhm.
Is that the Pentagon, is that kind of a simple model, but, we use a large language model. It was a couple years ago.
What model did you guys use? Do you remember? Just curious.
It's all homegrown, thing. When you say model.
So they have different models you can obviously download, and the architectural framework is there, right? So that you don't have to build it literally from scratch. Did you guys build a model from scratch, or did you actually download an existing architecture and then build on top of it?
Yeah,
Okay. Yeah, just kind of curious. Okay.
I think I work with submarines, and it's more about form factor and size. So obviously, if you want a good LLM model, you got to have a large form factor, so to speak, like the power, GPU, compute power to support that,
Hmm.
and then that's equivalent to the size, right? So the better LLM, the more compute power, the more GPUs, the better output, right? So form factor, we need that this big, right? So basically getting that onto a hardware, more of like a laptop or a tablet, actually be air gapped, so it's not connected to the network on board, but it's
Mhm.
a disconnected system, so that one, I can use that as a kiosk where I can ask the chatbot questions and it responds with the answers, and then they take that response and relay it back to whoever needs to get the answer to it. So I think a lot of times it comes to form factor and size. Bigger isn't always better sometimes because you can't fit.
Yeah, it's true.
You need to, make sure you have the right size needs to do certain things, but also the compute power too. Like how many data centers are being built right now to support
A lot.
all the
Yeah.
computing power to support everyone's using ChatGPT and all that. So that takes space and energy as well. So.
I see you back there 1 second. Do you connect that LLM to any other LLMs, or are you only using one? I'm just,
We're using one, it's Llama, it's like, I forget what version of it is, but basically, only one LLM is on that piece of hardware.
okay,
And it's disconnected because you can't connect the LLM to the network.
gotcha. Yeah, yeah. Honestly, that's the biggest challenge that I see, that I'm talking to clients about as well, is just how to solve that security and networking issue, air gap network, and getting the information into the hands of people in the field, operators, people that need it, at their fingertips, while still keeping the data secure. It's a huge, huge issue.
The Navy, specifically the acquisition process, they don't, when they build new technologies for the network, they don't really keep like, I need AI integrated into it, so it's not process.
Yeah.
Like, how do we add AI after the fact when it's not even built into the design?
That's a different problem, yes. We get that all the time. All right, in the back.
So we developed a concept for a mobile data center just to support AI infrastructure because the AI takes so much GPUs and power and needs to be air gapped. And so we decided to put it all into a mobile container just to facilitate and help with the computing power.
So you literally have a mobile hardware device the LLM runs on, that you take with you, that then can be connected in a local air gap network? Yeah.
They have a small one, it's not this big, and then we have entire like 40-foot containers and 20-foot containers that can be transported to bases and secure, access sites from all sites.
Yeah, that's really cool. It's a great example of just the creativity that you have to have when you're solving these solutions for the DoW. It's just not the same as it is in the commercial side. I've got colleagues that work on the commercial side of our business, and I always joke with them, like, you guys have no idea how easy you have it. It's like so simple, bro. Okay. Any other questions on LLMs? Any other thoughts, comments? I love the interaction, by the way. You guys are smart too. A lot of you are probably smarter than me on some of this stuff. So please chime in if you have anything else you want to talk through. Okay, good. All right, so this is agentic AI and multi-agent systems. This is where a lot of this is going, and I think the value is going to be highest as it relates to AI and how it's deployed. So if you look at like this LLM agent marketplace, you've got your training data set. We kind of already talked through machine learning data and how do you train it. That's public proprietary information. It could be either or. That's where you get your large language model, and then the LLM API is where you then can connect that large language model back into your orchestration layer. Down here, you've got your large language model that's built for finely tuned SLM. So it's a small language model. Has anyone in here actually built an SLM agent, like a small agent LLM that does a very specific task within a larger agentic ecosystem? Couple people? Yeah. So you're familiar with that as well. So really the differences between the top and the bottom is like, this is your large language model solving a generic issue, right? It's a pretty big agent. This is doing a very, very small task, maybe even within the subset of these tasks, or within the subset of the larger agentic system that you're building. Can you guys hear me okay? I'm kind of walking away from the mic, by the way. Good? Okay. On the right-hand side, you got your LLM agent operating system and your orchestration layer. So there's different ways that agents can interact, right? They can interact agent to agent through APIs. They can interact agent to human, obviously human to agent, and then agent to agent with the human in the loop interface. So a lot of the ways that we deploy this technology within the DoW, I'm getting in trouble by my cohorts back there, is to make sure that you have a human that's validating whatever the output is to ensure that it's correct, right? At the end of this agentic process, whatever that task is, whatever you're outsourcing in terms of your workflow to an agent, you usually have to have a human in the loop. We're probably never going to get to the point where we're going to have AI agents launching missiles for us and things like that, right? It's probably not a good idea. But we could have them get to the point where they're building through like all the intelligence, going through all of the different information, the typography, the threat analysis, all the stuff that these guys do on the intel side, bringing that information to us very quickly. So then we as operators, the people that run the drones, we can make the decisions very quickly on what we want to do to extinguish that threat, right? So I actually believe this is going to be huge within the Department of War. However, there's a lot of anxiety about this at the highest levels of the executive branch because the optics would be absolutely terrible if they created an agent that launched a missile, a weapon, something like that, killed civilians. Obviously, that would be a publicity nightmare. So anyways, so your orchestration layer is really the engine, right, of how your multi-agentic AI system runs. The top there just talks about the task input and outputs for the human, whatever you're wanting to get out of the agentic system. So I thought I saw a couple hands of folks that have actually implemented multi-agent systems. Anybody have any comments or just want to describe maybe something that you guys have worked on? Maybe it was one of those. Okay. No problem. Moving on.
Just to
Yeah.
anchor on this discussion about it would be bad for the multi-agent system to like shoot something.
Mm-hmm.
Or maybe not, right? If we're in the denied environment where the human in the loop is at a distance and can't see what the swarm is doing.
True.
Maybe at some point, you know, I was at another talk where they talked about the last targeted mile.
Mm-hmm.
You know, maybe at some point the swarm or the multi-agent system can shoot, right? For example, without the human in the loop. I mean, that's where I think you would get a big tactical and operational advantage. But you have to accept the risk, right? If they shoot the white ship, twice the red ship, for example. But I think for all of the younger folks thinking about this, I wouldn't completely discount a multi-agent system that could shoot on its own.
Yes. I'm trying to keep my personal opinions out of it as much as possible, but I agree with you, and I think if you kind of noodle this out in the long run, what will end up happening is our adversaries will start doing it, and they'll be faster than we will be. So in order for us to match that, you're going to have to allow the agentic systems to make decisions. So I don't know what that world looks like. It's probably pretty scary. We're a little ways out from that, I think, based on where the technology is, but it's a great point. I do think that that's where we're headed. So, any other questions, comments on agentic AI, multi-agent systems? Okay. I'm going to have to get through this pretty quick so we can get to the breakout here. So computer vision, anyone ever work on a computer vision project, machine vision project? Okay. Man, you're like the AI expert back there. I love it. You want to just describe your project? Maybe I don't even have to present this slide.
Pro-Hawk AI, and we did enhance night vision for DoD, for all our services. And
Yeah. That's awesome. Yeah, go ahead.
We're doing sonar analysis, so basically taking the sonar data from the UVs and then encapsulating it and then compare it to a library of what's out there, saying this the sonar this correlates to an object of a vehicle or another asset, obviously, or a machine.
Yeah, those are both really good use cases. The simplest one that I can think of would be if you have a Tesla or seen Tesla autonomous vehicles driving themselves, they're using computer vision along with some other technology we've just talked about in order to make that a reality. But you can kind of see the differences in how the human brain works versus computer vision works. The biggest difference is computer vision's like working off of statistical probabilities, not certainty. So it's going to tell you I'm 98% sure that this is this, I'm 15% sure this is this, but then how it knows that it's actually the thing that it's supposed to know is you continually train that model, going back to the machine learning piece we talked about before. That's how you're going to get the accurate predictions into the future. So again, beating a dead horse, data is the most important thing in all of this. If your data is not labeled correctly, categorized correctly, cleansed, all that kind of stuff, you're not going to be able to build these systems effectively. Okay? I'm going to skip this one just for the sake of time. All right, so artificial general intelligence, I think, is where a lot of people are trying to take this, a lot of very smart people, smarter than me, Elon, all these guys. This is where you really get into the AI thinking for itself, making decisions without human interaction. And if you really start to look into this and read about it, I think this is the technology that's going to be necessary to do what the gentleman here described, which is allow these agentic systems to make decisions where they don't require our input. They're basically running themselves, and they're getting smarter in every interaction they're having without us having to load data ourselves into the model. So this is amazing, all the research. There's tons of money going into this. I still think we're a little ways out from this being a reality unless the woman back here has actually implemented this. You've implemented everything else, but this is a little bit out there. But the future is pretty cool when you think about how fast the pace of AI innovation is moving. It's scary because in my job, I'm trying to research these things, stay on top of them, and I don't just focus on AI, by the way. I focus on all technology, so it's a lot. But it seems like every day I'm on the phone with a client and learning something new. There's some new tool, technology, some new innovation that somebody came out with. And I think that's the hardest part about implementing AI in today's world is thinking 6 months, a year, 2 years from now, things are going to be so much different. You have to prepare a more iterative approach to implementing AI where you're not trying to work off of an old waterfall. We have to document everything for 6 months or a year before we ever make any moves. My organization, a lot of companies that I've talked to are very into rapid prototyping AI models, getting into like quick MVPs, testing hypothesis against use cases very quickly to see, hey, does this make sense? Should we put more money into this or should we not? I was on the phone with the state of California. They had gotten promised this really cool AI technology for their BART transportation system. The company really hoodwinked them, quite honestly. Charged them $10 million for 12 months of work, produced zero value, right? And it's just a learning lesson where you really need to bring the right people in to have these conversations. This is a situation where it's not 2 heads are better than one, it's 1,000 heads are better than one, right? There's a lot of information out there. You got to do your research, use the people that are closest to you, use external consulting companies if you need to help. But if you try to do this stuff in isolation, you're probably going to fail. And again, rapid prototyping, quick MVPs, that is the key in this space, in my mind, at least. All right, we're getting close to doing the breakout. Hold on. We've kind of talked through some of the challenges here within the theater, so I'm not going to hit on this. Okay, before we do the breakout, let's talk through how to uncover AI use cases. This is kind of a 4-step framework and process that we use that I know a lot of other people have used as well. The first one is to really define the problem statement, organize your stakeholders, define ideal outcomes. So you want to know what the goal of the project is right before you start it. And then you got to think about the governance and all of those different things as well. I think a lot of people want to implement AI technology before they think about how it's going to actually function, how it's going to be governed, how it's going to be secured. If you don't think about that stuff, you're probably going to be wasting your time. The next step is really to think through the data and the infrastructure assessment, the data uses, the ingestion. He talked about the GPUs, how much computing consumption you're going to use, which data centers you're going to tap into. If you're using an air-gapped network, like what edge computing techniques may you need to use, things like that are all going to be a part of that kind of infrastructure assessment layer. Step 3 is the AI capability mapping. So that's where you really want to start to identify the technical approach, start looking at different AI tools and kind of understand and document the architecture of what you might want to build. And I think then that leads quickly into the next step, which is verifying your proof of concept, which I talked about earlier. That's where you're going to build your prototype, your MVP. You're going to spin that up quickly. Most organizations that I talk to can get that spun up in like 4 to 6 weeks. So if you're working with companies that tell you it's going to take 12 months to build a prototype or MVP, they're probably not being honest with you, and I wouldn't spend my money with them. That's just me. But this stuff's pretty quick. There's a lot of cool technologies that are out there. I didn't really even get into like low-code, no-code AI platforms. There's like Replit, there's Cursor, there's all kinds of different platforms out there that can speed up development times exponentially compared to what they were even a year ago. So make sure you do your research, like I said, before you really start to go down a rabbit's hole of trying to take something into production, because it's very expensive. Okay. We got there. This is where we're going to spend probably the rest of our time here, is talking through some of the use cases that you guys have. So during this breakout session, what I want you guys to do is just turn to your partner. If you've got a few folks you came together with, that's totally fine as well. Just start thinking through use cases within your unit, within your organization, areas that you think you might be able to deploy AI. And I'd like to see some of these use cases that we can kind of discuss as a group. The mic is on, right? So you can step up to the mic, you can sit where you're at, and let's just noodle through these together and then figure out, hey, is this something that AI can solve? Is this something that AI can't solve? And if so, maybe talk through some of the technologies that we could use. We've got some smart people in the room who've already implemented AI. So we're going to kind of make this a little bit of a whiteboarding session, if that's okay. Sound good? All right, so I'll give you guys maybe a couple minutes, just powwow, and then we'll come back together, okay? My bad. Hey.
Thanks a lot for the talk. Yeah. Appreciate it. Yeah, it's a lot.
Do you have a card on you?
No, I have you have your phone.
Yeah.
You just tap on it.
I don't think people want to participate in this use case.
Yeah, thanks. Yeah, just tap that on your phone.
Okay.
Yeah, and then then you tap that and it's got my stuff. It'll bring it up. There you go. You can save it, do whatever you want with it.
Nice.
But thanks, Darren. Yeah. So really, to take advantage of everything like multi-agent systems, all this thing you're talking about, we're going to be willing. We're going to have to be willing to accept the risk of will you let the system do the mission you program it to do with your take the reality. Will you let it do it? We used to.
It's the higher level folks that just, because they don't understand technology, they're scared.
It does. And they're worried like you said.
That's what's actually more scary.
Particularly in how fast this next fight's going to happen. People are going to freak out, all the human factors.
Yeah.
Okay, so you shoot the wrong one, but guess what? That guy was in the wrong place. Like, you shouldn't be in the Taiwan Strait if the shit hits it. Because
That's where it's going down. That was one of my 5 major areas.
Yeah, but it's really, really interesting because I worked on destroyers, right? And we had these It has what's called something special. The computer will shoot on its own. You can take man out of it. So, but it does work. We tested it. The problem is you're going to go through the ammo as fast as the system can do it. So that's why we didn't use it, right? It was meant for like, you know, the Russians are shooting 15 cruise missiles at you, and you can't, you just
you just
turn it
gotta
on
react,
and
yeah.
just let it do it.
Yeah.
But it would work, but you'd be out of ammo.
And you're sitting back at that
Yeah,
point.
and then you're March. So anyways, yeah. But like I said, I'm located here in Hawaii, connected to the military network here.
Yeah, I'd love to.
Surface warfare. Yeah. So you just like, so that's
is this me, or what do I do?
that'll be sharing with me. If you go back, you download the contact, then it turns it into one of your phone ones, and you can just say done, and it'll probably tell you to save it. And it should be, if you go back to your contacts, it should be in there. Hopefully. It worked? No? Should have worked. Anyways, or you can, Joe, Ring, R-I-A. Yeah. The number is 808-994-7020. Yeah, Joe at El Capitan Consulting. The company's El Capitan. I'm just giving you my email. Yeah, Joe at El Capitan. TAN Consulting. And I'm independent, so I'm able to support, you know, various clients
No, that's
on big
great.
projects, or just like, hey, we just want a guy that we can call when we have a question. I'm willing to do those arrangements.
Yeah, I'll hit you up. Actually, my wife, she works for a consulting company. She's here as well. You may see her down. Her name's Desiree. You may want to work with her too. We're trying to do more work. Not Apex, but
Yeah.
she runs. We're trying to do more work within the military, but we have facilities. The CEO is a former CISO. He's for 20 years. He got a lot of contacts, a lot of great offering. Yes, so they're gonna help sponsor us and actually bring work to the DoD. So we're in the state space right now, but so she's here kind of looking for a sponsor and stuff like that. Great to meet you.
Yeah.
Having contacts and just this is cool stuff. I love.
Yeah.
My brother's still in the Air Force. They actually called him back. He was a civilian. Got out of the Air Force, civilian. So they just called him back to duty. So he's out here too.
Yeah.
Busy time, lot going on.
It is. It is. All right, brother. Good to see you.
Yeah. All right, you guys good to come back together? You need a couple more minutes. Okay. All right, we'll go like 60 more seconds. You guys are solving the world's problems over there. I hear you. I can't wait to hear it. That's how I got this part-time AI job too. They're like, hey, you can get on AI task force as well. Sounds good. All right, for the sake of time, let's come back together and then we can share some of these use cases. There we go. All right, so who wants to go first? You guys? Cool. Do you want to stand up or you want to be there? Either way is fine. Perfect.
ATO.
Okay.
So that's kind of like part of our sidebar. You can't do anything until your system's authorized. We all know about the ATO, all the different processes. If we cannot move fast enough, right, to
Yeah.
get applications out onto wherever your environment is without the ATO. So how can we use AI to fix that?
When you say fix that, are you saying use AI to speed up the ATO process? Like the documentation process, the workflow, the approval process?
It's all about security. The whole purpose of an ATO is to make sure that your environment is secure.
Yeah.
So this would be what generate automate this scanning and then generate the documentation
On the software itself?
of the whole environment.
Okay.
Right, the hardware,
Yep.
software, all the connections, right, make sure it's all secure. And then from that, automatically have a validation of the environment and then the documentation. And of course, at the end, the AO just needs to say, okay, 30 seconds later, it's done. Now, if you're in continuous monitoring and using the AI along with the cybersecurity tools to be able to monitor the system and make sure that your SOC and your CSSP are monitoring that.
That's actually a really cool use case. I've thought about it from the documentation side, the compliance side. Yeah, writing an agent that can do that is possible, right? It's not impossible. I think it's a heavy lift, but probably worth it based on how long it takes to do right now, right? Yeah, no, that's a great one. Love it. What about you guys? You want to talk through kind of some of the things we've discussed a little bit?
Sure, yeah. I mean, from a weather forecasting standpoint, we know that a lot of it's possible right now, but our biggest task manpower-wise is basically watching the weather for different locations or regionally, and then producing flight weather briefings for different facilities going from point A to point B to point C. And then providing the in-flight weather for turbulence, icing, flight hazards, and all of our data is gridded. We have live data for most of our locations, like whether it's radar or satellite from top down. So having a flight weather briefing agent, and we know that this is happening on the commercial side right now.
Yeah.
So, but it's just getting that implemented and having it trusted on the DoW.
What's the biggest hurdle or challenge you guys are facing right now around that?
Program office.
Got it. logistical challenges that we put in front of ourselves.
I know there's DISM in every sense, what Air Force, whether it does Army support, you know, their ATO is different from our ATO versus, that's, you can operate our radar stuff on Army networks.
Oh, I didn't realize that. Even within military branches, it's different.
Yeah, like, it's so convoluted where.
They don't have like an overarching DoW
I can't
standard.
take a Navy system that's ATO to put on an Army system, because it's gotta meet their specific ATO requirements. So like, the interoperability of similar systems on different networks, of different branches of the military, I can't connect.
I mean, there's reciprocity, but again, it's just gotta be, you know, it's easier if you are an ATO to one system, but it's not like that. So I was a naval aviator and now a commercial pilot, and I considered my command sheet with my iPad, with Garmin flight, do all that. Put it in my flight plan, and it will give me all my airspace warnings, all my terrain warnings, give me all my weather route, I do all that icy map out to record. So, like I said, it's there commercially.
And I have 6 people sitting there right now doing that. I know.
And then it generates a 27-page brief, which I never did.
You get ChatGPT to summarize that for you.
Actually, I just look at the picture and say, yep, I'm good to go.
There you go.
Yeah, it is a.
Rubber stamp it.
Whole regulation and policy type thing that, is gonna require a big change in mindset.
So on one of the slides that I skipped, interoperability was one of the challenges kind of between military units. You know, as you're implementing, you know, agentic AI, multi-agent systems, things like that, they're going to have to interact across military units. That's going to become really challenging, I think, and you guys are obviously identifying the core issues that we just kind of get in our way with a lot of the different policies and rules that govern that. I was talking to this gentleman, he actually left, Joe, he was in the Navy, and you know, he was saying that eventually you're going to have to just give the machine the ability to do that stuff and execute these tasks, and you got to get out of the way, because truthfully, humans make more errors at this point than machines do. And so we are being ultra careful trying to prevent machines from making mistakes when, in essence, humans are making a lot more. But that's a tough thing, right? Because we've got human pride, and we want to believe that we're really smart and we can, you know, do things really well, and we don't want to believe that someone could program a large language model in a couple years, it's smarter than us. But it's happened, it's real, and we need to embrace it. So, do you have a comment? Or?
No, and again, it's like psychology for, you know, Tesla's safety records in autopilot is better than any human.
Yeah.
However, you know, if one Tesla crashes, it's on 22,
Yeah.
it's supposed to kill 50,000 people a year.
Yeah.
And highway.
Yeah, all of a sudden the one accident just negates everything else, all the other ones that didn't crash.
This must be a DOW.
I know, I'm trying to get used to it, it's so hard.
Anyhow, it's the policy, we're trying to create policy from the bottom up, like it needs to be DOW needs to go, hey, here's your ATO, here's your AI policy, and we all pull it down versus everybody creates a different one, and then they don't mesh at a joint in.
They delegate, like a lot of.
It's delegate, that's
Or
right.
they make a policy that's very broad in scope, and then they expect like the echelon commands to make up their own policy, and then they're like, and then those commands don't communicate with each other, so they're not like stepping each other's toes, so like we're aligned and not misstep. And then those commands relying on the other commands to make a policy there, which is like, I don't start until you start, I'm not starting until this guy starts, and we're all on different pages. Which is just, that's how it works.
Yeah.
Because we're trying to.
I feel like I'm back in the military again,
We're
fellas.
trying to do like a.
Hurry up and wait, hurry up and wait.
Indo-Pacom AI roadmap,
Mhm.
like what is the AI roadmap for Indo-Pacom tactically and all that stuff. And then we go talk to the people that are like, yeah, we don't have a strategy yet. So it's like we're waiting on these other people to come up with strategies, and it's like, well, they're waiting on you guys to come up with a strategy, we'll copy
Yeah.
you guys. So it's chicken or the egg concept.
Yeah. All right, I know a couple other folks left because I didn't get over to that side of the room, so I apologize. You guys in the back, I know you're super smart. You got something for me, right? Some really cool use case.
All yours.
Oh, I'm sorry, I wasn't paying attention to what you were talking about.
His use case is his company does tracks movements with watches.
So, okay, so I'll take it.
All right, here we go. The Godfather's coming up.
No.
So was the data input a watch? Like, maybe I missed the beginning of that. I heard something about a watch.
So we are a strategic partner with Samsung.
Okay,
Samsung has given us authorization and access to the core data that the watch detects, not the process data. With that core data, we apply our algorithm. So this watch has 3 algorithms running on it. I'm being reported daily to Hobart, Tasmania. I know exactly where I am, what I'm doing, how I'm responding. Right now, it's probably showing my heart rate is way up, and I'm trying to do something that's out of normal. But the watch is where we started, because that's just where we started. We now have a pupillometry option, so we can look inside of a VR system with your eyes and how you're responding to the stimulus through the VR system. And we're multimodal. We can take all kinds. We've got another one where we're now sort of working with a company that's developed the coolest thing I've ever seen. They use Wi-Fi to look through the walls and see what's going on the other side of the wall. I don't even know how it
I've read a
works.
little bit about that,
I don't
actually.
even know how
Yeah.
it works, but I've seen it and it works.
Mhm.
So that's just another modality that's being put into our response of how's the human performance. Once you've got that information from the Wi-Fi input, how are you responding to it, et cetera, et cetera. So anyway, that's what we're working on. That's what we're having an intense conversation about.
Thanks for sharing. That's amazing. It kind of just goes back to the point. There are just so many different really cool use cases, and we're just scratching the surface right now around AI and what's possible. And we get to the artificial general intelligence kind of stage. I think the stuff that we're going to see is going to be wild, right? Compared to where we're at today, just the way that we fight wars, interact with other nations is going to be completely different. Not even sure we're going to be sending troops in anywhere ever again. I think that's probably self-evident. If you're sitting in this room, you know that's probably the reality into the future. So, yeah, I appreciate you sharing. Anyone else want to share? I don't want to leave anybody out in case you guys got something. Good to go? Okay. I think we're right on the cusp there. Are we good, Alex? Okay. Thank you guys for coming. Appreciate the time. If you have any questions after, let me know. Take care.